This is Mark Vanis, doing a comprehensive guide to projectors. In the evolving landscape of visual presentations, projectors are pivotal tools for delivering immersive and impactful visuals. In this interview, we will discuss how projectors work, different light sources, different types of projectors, lens ratios, and screens. A projector is an optical device that receives a video signal and projects the corresponding image on a projection screen using a lens. They can also be used to project on different surfaces and create several unique experiences using the content provided. Every projector has a light source that creates white light and is focused through a light path or light pipe. From there, the white light is separated by a series of dichroic mirrors or a beam-splitting prism where the individual colors are processed, combined, and projected through its lens. How the white light is separated is determined by the type of processing being used in the projector. There are three main types of illumination used in projectors today: lamps, LEDs, and lasers. Lamps used in projectors include UHP, ultra-high pressure, and xenon arc lamps. UHP, ultra-high performance lamp, is compact, extremely efficient, and has good lumen maintenance. It has a cooler color temperature between 7 and 8K Kelvin and typically has a limited lifespan. The other lamp type is the xenon arc lamp, where white light is produced by a xenon bulb, which is better saturated in the three primary colors, is in the daylight color spectrum, and requires high power. However, it has poor lumen maintenance and will flicker toward its end of life. LED projectors use red, green, and blue LEDs, creating a wider color palette, and can be used with LCD or DLP projector imaging technology. This technology is not widely used in large venue projection. Three different laser technologies are used. That is, the use of blue laser diodes, the use of red and blue laser diodes, also known as a laser phosphor hybrid, and the use of RGB laser diodes. Blue laser diode projectors shine light through a yellow phosphor wheel to create yellow light. The yellow light is then filtered through to the three primary colors RGB. Laser phosphor hybrid projectors use blue and red laser diodes. The blue laser diode shines through a yellow phosphor wheel to create yellow light and is then filtered to separate blue and green, while the red laser diode is introduced after the phosphor wheel. These hybrid laser projectors outperform lamp-based projectors in brightness while delivering superior color and long life. RGB laser projectors, also called direct laser projectors, use three individual colored lasers. This allows for a wider color gamut. They can reproduce DCI, P3, or Rec 2020 color gamuts without a color filter. RGB lasers are considered to be the best projector light source available. However, using this technology is very expensive as they tend to be physically larger than other projectors and are currently best suited for installations and cinema. Using laser diodes for projectors has better overall image quality with a wide color gamut. They are energy efficient, have instant on-off ability, have flexible installation options, and have longevity. Overall, laser is the future and technology is only getting better. There are two main types of image processing: liquid crystal display, LCD, and digital light processing, DLP. There are other forms, including liquid crystal on silicone, LCOS, and digital direct which is a form of Alcos and the grandfather to all the cathode ray tubes, CRT, no longer used. The latter are less used in the rental and staging industry compared with LCD and DLP. In LCD projectors, white light is generated from a lamp or laser diodes, which travels through the light path and several different dichroic mirrors. It is a mirror coated in a special film that reflects only a specified wavelength of light. While going through these mirrors, the light splits into RGB, and then each light passes through an LCD panel. All three light colors are passed through a dichroic prism/cube. Four triangular prisms converge to form a single image, and then through and out the lens. With today's technology, LCD projection directly competes with single-chip DLP projectors. They are easily found with brightness over 10K lumens or more, and are relatively cheap compared to DLP projection. Some disadvantages you see are low life due to degradation, and most LCD projectors are non-sealed. Non-sealed is the term used to describe the light path, panels, and cube not being sealed to outside elements. Dust, dirt, and even fog juice can settle and cool on the various pieces that make up the light path of an LCD projector. DLP, digital light processing, is a technology that uses a digital micromirror device, DMD, to create an image. There are two main types of DLP projectors, 3-chip and single-chip, that use DMDs. A DMD is a digital micromirror device that is an array of very small rotatable mirrors. Each mirror is 10 by 10 to 17 by 17 micrometers, depending on the DMD. These micromirrors can be mechanically tilted in an on or off state depending on the signal's pixel information. DLP projection starts with white light being generated from a lamp or laser diode. The light travels through the light pipe that includes an integrator rod, relay optics, and folding mirror. From the folding mirror, the light goes through the total internal reflection prism, TIR prism, which consists of the beam splitting prism, individual color prism, through the DMDs, then all converging back through the TIR and out the lens. DLP has the highest brightness, best video performance/fill factor, best uniformity, and is best for a multiple projector blend application. A single chip uses a color wheel through which white light is passed, creating the different colors needed for an image. Single chip DLP is in direct competition with LCD, even though technology has improved since single chip projectors were introduced to the industry. Some may still see the rainbow effect caused by the color wheel. Common inputs that are found on projectors include SDI, HDMI 2.0, HD-Base-T, DisplayPort 1.2, and some have begun to incorporate fiber SFP module inputs. It gives the projectionist the ability to move the lens to fit the screen. This moves the image onto the screen and does not affect image geometry. Keystone. Having more shift gives more flexibility for positioning. A lens with reduced lens shift may be called an on-axis lens. Rigging or flying is a term used to describe hanging a projector. Smaller projectors utilize fly brackets with a single rig point. Larger projectors use rigging or stacking frames and utilize up to 4 rig points. The larger projectors typically come already installed in a rigging frame, and the smaller ones would need to be requested. If not needed, then the smaller fly bracket would would suffice. The image will look off if not physically aligned perfectly. That is when we use warping. It can also be called geometry correction or keystone correction. Ideally, you want a projector to point in perfect physical geometry to the screen. However, when this is not possible, warping can alter the image to appear geometrically accurate. Warping is also important, almost unavoidable, when stacking two converged projectors together. Can be, yes. Stacking is the term used to stack multiple projectors making the same image at the same location. Projectors are either physically stacked on each other or set beside each other. This not only adds brightness, but also adds a hot failsafe or backup. Great question. That is when we blend multiple projectors together on a large widescreen seamlessly. For example, 45 by 15. You can control the blend in the projector or in some switchers, processors, or media servers. The same principle is used, but on a more intricate level. Projection mapping is a video projection technique in which video footage is mapped onto a surface, turning common objects, such as buildings, runways, stages, and even water, into astonishing displays. Projection mapping software is used to map a 2- or 3-dimensional object spatially. The software mimics the real environment the object will be projected onto and can be used to create ads, storytelling, and more. Some of the most common projection mapping software used is Disguise, Pixera, Resolume, and MadMapper. An example of projection mapping can be seen in the picture below at historic Ford's Theater in Washington, D.C., where projection designer Clint Allen utilized Epson laser projectors to bring modern projection mapping technology to this musical. For any given projector, the image's width, W, relative to the throw distance, D, is known as the throw ratio, D divided by W, or distance over width. Throw ratio, or throw divided by width ratio, is what we track most. There are two types of lenses I want to mention: fixed lenses and zoom lenses. A fixed lens has one ratio, there is no zoom. A zoom lens has a wide to telephoto range. No, Barco lens ratios are based on the ratio of the PJ meaning SD, HD, WU, 4K, while Epson lens ratios are based on the chip size of the projector. In general, the lens ratio, LR, posted on the lens is multiplied by the screen width, SW, to find the projection distance, PD. LR multiplied by SW equals PD. You can also divide PD by SW to get LR, or PD by LR to get SW. A screen or projection surface is the usual target for a projector. Screens come in many sizes, but typically have a certain aspect ratio and width to height ratio. The most common today is 16 by 9 HD. There are other screen ratios for widescreen projection, such as a 30 by 10, 3 by 1, which requires multiple blended projectors. Other projection surfaces can be buildings, walls, mountains, or spherical domes. The choice between a front or rear surface for your show typically depends on where the projector is located. A front surface reflects light back to the audience. A rear surface has transmissive material that allows light to pass through with some refraction or diffusion. Some screens may be specified for both front and rear projection with one fabric known as a dual projection surface. The front projection performance is often lacking compared to a purpose-built front surface. Screen Most of our front surfaces are +1 gain. High gain screens above 1.0 reflect brighter images but have reduced viewing angles and can also be prone to hot spots. Hot spots are areas that appear brighter than the rest of the screen. One way to avoid hot spots is a low gain screen below 1.0. They will have less light to the eye but reduce hot spots from short lenses and help projector blends look good from a wide viewing angle. The two main types of screen systems are fast fold and modular. Fast fold screens are collapsible frames with a folding design that allows for quick, straightforward setup and strike. Snaps attached to the screen surfaces. Fast fold systems are commonly found in the rental and staging industry as an inexpensive solution for breakout rooms. Measurements are referenced by the picture or viewing size. For example, 20 by 11. Stumpful is the main manufacturer of fast fold screens we own at Four-Wall. The main model is the Monoblock 64, which ships with a front and rear surface. Inventory ranges from 10 feet wide up to 24 foot wide. Legs and drape kits are available. It is a large format screen system built for the rental and staging market. The primary construction is a dual aluminum square tube with supporting cross members. The screen surface, or fabric, attaches with bungee loops, creating positive tension. We package the modular screen system to ship in individual cases for airline or small cargo transportation. We can create any size out of existing parts in select offices.